I notice this is not a proper fraction. The degree of the top and the bottom are equal. So two ways of doing this. I've seen students come up with a really nice trick, but you would normally use long division. You would take the top and you would divide it by the denominator. And you would say x divided by x is a 1. That's x minus 4. Subtract. So you would say this is the integral of 1. And the remainder is 6 over x minus 4. Same as what you did back in the days in algebra. This is x plus 6 natural log of absolute value of x minus 4 plus c. Done deal. I've seen some other students use another trick that I really like, and let me show you. So this is one thing you could do. Long division, that's how they do it in the book. You could take this fraction, you could take this, I meant to say integral. Okay, this is running awkward. Let's do it right there. Here we go. So you could look at this and say, can I get the denominator out of this? Can I get that to be x minus 4 plus what? So how does it work? I have x plus 2. What do you add to negative 4 to make it x plus 2? Can't you say plus 6? This I learned from students. Isn't x minus 4 plus 6x plus 2? And you could split them up. You could say that's x minus 4 over x minus 4 plus 6 over x minus 4 dx. And isn't that a 1? So you get the same thing. So do you want to do the long division? Do you want to do this trick of adding and subtracting? I normally do long division, but students have shown me that trick, and I thought I'll show it to you. And on my end, I can care less what you use. Whatever makes more sense to you, go ahead and use it. Okay. If I look at the next problem. Now we're starting with a different combination. That is, I'm looking at x plus 2 over x minus 1 squared. Well, if you see any power, you have to list it that many times. So the least amount of work you could do is list this twice. You have to. You have no choice. This is linear. That's an A. Even though this is quadratic, the fact that I could write this as x minus 1 times x minus 1 qualifies it to be one of the factors which is linear. The top is 1 power less. One more time. If I can factor the denominator into linear factors, this will count, even though it's quadratic, it'll count as a linear factor. One would it not count? That's 2 examples from now. Now what? The same as before. Clear the fractions. There it is. Now, which values of x are you going to choose? Well, we're going to let x equal, what's the domain? The domain x cannot be a negative 1. Let x equal negative 1. I'm going to get negative 1 plus 2 is 1. And negative 1 there, that's a 0 plus b. I got b. We have a problem. There is no other x value for me to choose in the domain. Then guess what? Choose any value. Let x equal any value other than negative 1. How about 0? If you put a 0 there, isn't that 0 plus 2, which is a 2? A 0 there, isn't that a times negative 1? Plus b, but I know that b equals a 1. Solve that equation and you're home free. This says negative a equal 1, so a is negative 1. So if this is a negative 1 over x minus 1 plus b over x minus 2 squared dx. Let's see how this works. This part is simple. That's natural log of x minus 1. How about this? Ooh. We said b was a 1. How about this part? This part is, I'm looking at the integral of 1 over x minus 2 squared dx. If I let u equal x minus 2, du is dx. So this is the integral of, this is my u, and this is my du. Isn't that the integral of u to the negative 2 du? Look at that, I'm already thinking of the answer. So wouldn't that be add 1 to the power, divide by that? So this will be negative 1 over u, and remember what u was? So don't rush and write natural log unless that's a 1. It's not a 1, it has to be something other than a natural log. And here's another example like this, sort of speak. So if I take this and say, okay, let's see how this works. Again, the core of the problem is taking x squared plus 5 over x minus 1 squared and figuring out where this came from. That's all there is. If I see a power of 2, I have to list it that many times. If I see it cubed, I have to list it 3 times. So the goal is, this is linear, that's A. This is the product of two linear factors. This is x minus 1 times x minus 1. It counts as linear. And this is linear, that's a C. So if I clear the fractions, x squared plus 5 equals A. This is missing an x minus 1 into x plus 2. This is missing just an x plus 2. And C, the only thing that this is missing is an x minus 1 squared. And now if I was to ask what's the domain, you would say x cannot be a 1. Start with that one. Let x equal a 1. 6 equal a 1 there, that's 0, no need to write it. A 1 there, that will be b times 3, and a 1 there, that will be a 0. So what's b? I could say b is 2. What's the other value? You can't have x equal negative 2. Well, let x equal negative 2. Negative 2 squared is 4, plus 5 is a 9. A negative 2 there will make this term a 0. A negative 2 there will make this term a 0. A negative 2 there will make this c into negative 2 minus 1 is negative 3, squared is a 9. That means c is 1. Now, I used both numbers. There are no other numbers. Pick any number you want. Let x equal, actually, let me put it right there. Let x equal any number. 0 is a nice number to pick. If I put a 0 there, that's a 0, that's a 5. A 0 there and a 0 there. Isn't that A? Negative 1 times negative 2 is negative 2. B, I already know what B is. A 0 there, that will make it a 2. C, I already know what C is. If I put a 0 right there, isn't that negative 1 squared, which is 1? So, isn't this saying 5 equal negative 2a plus 4 plus 1? That's 5, right? So that means what? 5 equal negative 2a plus 5. Negative 2a equals 0, so a is 0. So this is gone. What does that mean? That means this is actually the integral of 2 divided by x minus 1 squared plus 1 over x plus 2 dx. And this problem we just did in the previous, if you have it to the negative 1, that's like adding 1 to the power dividing by that, you end up with 1 over x minus 1 negative. Right? And if you're not sure, go on the side and integrate 1 over x minus 1 squared dx. That's the integral of x minus 1 to the negative 2 dx. Add 1 to the power divided by that. And this is a natural log of absolute value of x plus 2 plus c. And that would be my final answer. Again, the busy work in this is figuring out where the fraction comes from, nothing else. And I have a couple more to go, and I'm touching on all the different combinations. And here you'll notice this problem is a proper fraction. That's x squared over x cubed. So x squared minus 5x plus 1 over x squared plus 1 into x minus 2. X minus 2, linear. X squared plus 1. This is not linear, and I can't write it as the product of linear factors. This is quadratic. To make this a proper fraction, what's 1 power less than quadratic? Linear. A linear equation is bx plus c. Quadratic is bx squared plus cx plus d. So now we do the same, except now it's a bit messier. If I clear the fractions, this is missing an x squared plus 1. And this is missing the x minus 2. So before I proceed and get all the x squares and use the book's method, because this can't be 0, I would still use the 2. That'll save me time. If I let x equal 2, 2 squared is a 4. 5 times 2 is 10 plus 1. If I put a 2 right there, that is 2 squared, that's 4 plus 1. And if I put a 2 there, that's a 0. So this pretty much says negative 5 equal a times 5, which means a is negative 1. If I know a is negative 1, this is going to save me a lot of work, because now I have 2 more variables and no numbers. I'm going to follow the book's method, but I'm going to follow it by using a negative 1 instead of a, and that's going to make this problem a lot easier. That is, I'm going to say x squared minus 5x plus 1 equal negative x squared minus 1 plus bx squared minus 2bx plus cx minus 2c. We're going to say x squared minus 5x plus 1 equal the x squares. Notice instead of a, I already know that's a negative 1, plus b. In front of x, I have a negative 2b plus c. And the number that has no x, I have a negative 1 instead of a, plus minus 2c. So what does that mean? That means in my system, the number in front of x squared must equal a 1. And the fact that I already found a, that's going to get me to figure out what b is automatically. And the number in front of x must equal a negative 5. So the negative 2b plus c must equal a negative 5. But I know what b is. So negative 4 plus c equal a negative 5. I get c to equal a negative 1. And I'm done. b is 2. C is a negative 1. So the busy work is done. That's negative 1 over x minus 2 plus 2x minus 1 over x squared plus 1 dx. Now what? Now what you do, you say, well, this part is negative natural log of x minus 2. That's easy. This part, you're going to split it up. You're going to take 2x over x squared plus 1 dx minus 1 over x squared plus 1 dx. So this is going to be negative natural log of x minus 2. This is an inverse tangent of x. We know that already. This part, I'm going to work this out right here. I'm looking at the integral of 2x over x squared plus 1 dx. If I let u equal x squared plus 1, du is 2x dx. This becomes the integral of u. 2x dx is du. Isn't that natural log of absolute value of u? But what's u? Isn't that x squared plus 1? And don't forget the plus c. And I have one more to go. And this should touch on almost all the combinations that you come across in the homework. So how hard is this problem? How quickly can you figure out where this comes from? Since this doesn't factor, I can't factor that. Since that cannot factor, I'm looking at 2x squared minus 5x minus 2 over x minus 3 into x squared plus 2x plus 3. And if I can't factor that, I could try and figure out, well, that's x squared plus 2x. Let me complete the square on it at least. Half of the middle number is squared. That's a 1. So that means minus 1 and a 3. That's x plus 1 squared plus 2. Doesn't help at all because that can never equal 0. Okay, at least I know what it is. So now what? Now I'm going to take this and say, okay, well, look. This is over x minus 3 and over x squared plus 2x plus 3, which is, right there, I already did, that's not a waste of work. This is linear, the top is 1 power less. This is quadratic, the top is 1 power less than quadratic, which is linear. Clear the fractions, the traditional. And this is missing that denominator. And this is missing that denominator. Now the book will go ahead and distribute and clear things out. Before we do that, we're going to find a. How do we do that? Let x equal 3. Wouldn't that be 3? 2 times 9, 18, minus 3 times 5, 15, minus 2. A times a 3 in there, that's a 9 plus 6 plus 3. A 3 in there, that's a 0. What do we have here? We have negative 17 plus 18 is a 1. We have 9 plus 9 is 18. A is 1 over 18. We got this to be 1 over 18. Even though it's a fraction, it's going to save us time. Now what? Clear the fractions. 2x squared minus 5x minus 2 equal 1 over 18 times, actually, right there, I already cleared the fractions, equal 1 over 18x squared plus 2 over 2 over 18, which is 1 over 9, x, plus 3 over 18, that's 1 over 6. Here, if I FOIL this, I'm going to get bx squared minus 3bx plus x plus x minus 3. So here I would say 2x squared minus 5x minus 2 equal. I want the numbers in front of x squared, the numbers in front of x, and the constants. In front of x squared, 1 over 18 plus b. In front of x, 1 over 9 and negative 3b. And the numbers 1 over 6 and a minus 3. Oh wait, was there a 1? Plus 1. Right there. Yeah, I missed one number. There are 3 terms. This is an x, that's 1 over 9. This has an x, and this has an x. Okay, that will work. Oh, that's C. Oh boy. Okay, let's get that right. So that is bx squared, got it, minus 3bx plus cx minus 3c. On the previous problem, did we get that? Yeah, we got the c. That's good. So if I look at this, I'm thinking the number in front of the square must equal the number in front of the square. That means 36 plus, or actually we could just go about it right away. No need to do it like pre-algebra. So we could say that means b equal 2 minus 1 over 18. That would be all over 18. 36 minus 1 is 35. This part, is that a 1? Let me make sure. The number in front of x, okay, yeah, that should have been a c. My mistake, right? Yep. And the number without, that's 1 over minus 3c. There we go. Okay, so now what? The number in front of x is this mess, and that should equal the negative 5. So negative 5 should remember, I already found b, 35 over 18. The only thing I need to find now is a c. Do you see that I could take the blue, plug b in, or can't I say instead of the blue, let's look at the green. Doesn't that say 1 over 6 minus 3c, and what is the number? Isn't that easier? So here I have a choice. And what would that be? That would be negative 2 minus 1 over 6 equal negative 3c, or 12, negative 13 over 6 equal negative 3c. So if you multiply by 1/3, c will equal a 12 over 18. positive. So this is what I got. I got this whole mess to equal 1 over 18 over x minus 3 plus 35 over 18 plus 12 over 18. This is x over x squared plus 2x plus 3 dx. That's 1 over 18 natural log of absolute value of x minus 3. Very good. I got it. Now what? Now I'm going to split the rest. I'm going to take 35 over 18, the integral of x over, and we did figure out what this denominator equal. This denominator is right there. We figured that that was x plus 1 squared plus 2 dx plus 12 over 18 plus 12 over 18, the integral of dx over x plus 1 squared plus 2. So that's going to equal 1 over 18 natural log of x minus 3 plus 35 over 18. And if I look at this problem here, I have to make a substitution right there for this piece. I'll work this out on its own. But this right here is 12 over 18, which can reduce by 6, right? But this is, that's a, what do you square to get 2, radical 2? 1 over radical 2, the inverse tangent of x plus 1 over radical 2 plus c. So pretty much, this is my final answer. There's only one piece left, and that piece is gonna take a bit more work, just a bit, and let's do that. Okay, so if I take the integral of x over x plus 1 squared plus 2 dx, if I let u equal x plus 1, du is dx. So this is going to become the integral. This is my u. There is no easy way around this. And as for the top, dx is du. I still have an x left. Remember that trick? What does x equal? Isn't x u minus 1? So if I take this and I say this is the integral of u over u squared plus 2 minus 1 over u squared plus 1 du. Wouldn't that be here I let w equal u squared plus 1 plus 2. Let w equal u squared plus 1. dw is 2u du. So, there. I know what this is. That's an inverse tangent of u, right? And what would this be? Isn't that right there 1/2? Oh boy, I need more space. Okay, I'm going to write the whole thing here. That's 1 over 18 natural log of x minus 3 plus 35 over 18 times 1/2 natural log of w. W is u squared plus 1. And u is x squared plus 1. Or x plus 1 squared plus 1. Minus inverse tangent of u. And u is x plus 1 plus 12 over 18 times 1 over radical 2, the inverse tangent of x plus 1 over radical 2 plus c. Look at that beauty. And that would be it for this section.